Okay, this is going to be a demonstration of the mtable importing scheme that I've been putting together for Robert. Basically, I'm just going to go through and import the latest FDNS data by copying it into the bit discovery outside Intel database S3 bucket, and I'm going to copy it from Snake 4 dev server. This would eventually be happening directly from Snake 3 across the network. So I'm going to show this by showing a flow diagram of the overall process, and then we're going to drop in and take a look at the S3 bucket content, and then I'm going to copy files and trigger a capture of mtable data, and then we'll watch the S3 bucket notification logs. We'll be watching a log that shows the files getting captured and a job getting kicked off to actually build an AMI, test the new mtable data overlay on top of an existing snapshot. And then I'll just be going over some manual steps required then to actually release and deploy that AMI. Okay, so the overall workflow goes something like this. We sort of bracket the actual capture of files by using a similar scheme that Robert has in place already for so-called zignore files. In a given directory, we drop in a zignore file, and then we add some mtable data, and then we remove the zignore file, signaling that we're done with a capture session, and basically the files that were dropped in during the lifetime of that zignore file wind up triggering a job. That job winds up basically copying the data that was added onto a snapshot, a stable snapshot of the OI data that already exists. And once the data has been overlaid, we run a test suite of outside Intel. We also remove old mtables that match the same file pattern as the stuff that's being added to keep the snapshot from getting huge. And if those tests pass, an AMI is generated, and that's sort of like the success path. And once that AMI is out there, we can deploy it out to the load balancer farm using some manual schemes. Now, if tests don't pass and we get a failure, currently we don't really handle that really gracefully. Some cruft is left around in the S3 buckets, and so there's some work that needs to still be done there. But I'm just going to demo what we have so far. Okay. So I have an SSH window into Snake 4 right here, and we've got a screen session going on here. And essentially, I'm going to run a couple of S3 commands to copy some new files that were dropped in here. So looks like there's a couple of new mtable files here for this date. So I'm basically going to start out by creating a so-called trigger file in the same subdirectory as where my data is going to live, which is data2, FDNS, and mtable. So I'm going to put that in a separate window here in my screen session. And I'm going to start by actually creating that zignore file because it actually doesn't exist right now. And I'm going to touch I'm going to name it that. Okay. And then I'm just going to copy that file onto the S3, into the S3 bucket. Now, let's take a look at the S3 bucket real quick before we do that. I've got a couple of commands here. I'm just going to drag just to show what I have. Yeah. This command down here is going to show me a recursive listing of the entire bucket. Okay, so there's a top-level archive directory and a top-level data directory. Let's not worry about the archives for now, but let's do a listing of the data directories. This structure basically mirrors the same structure as exists on the OI API servers, the data directories. There's the FDNS directory and the WHOS directory. So the file that I touched, I'm just going to basically copy into the same directory structure as is on the S3 side. And that is this command right here. Okay, so that if I do another listing now, it should show up there. Yeah, the ignore file is created there. Now you notice that a capture directory was created here. This capture directory was basically a direct triggered by the creation of this zignore file. Now I'm going to kick off another window here and watch some logs here. This is watching this CloudWatch log that is generated by the Lambda functions that I've hung off of the triggers on the S3 bucket. Okay. So here you see that this zignore file was created and it began a capture. Okay. This stuff, don't worry about it too much, but essentially this thing is watching all the files that are being created, and it only cares about some of the files, not all of them. So the stuff that it captures, it actually creates it and puts it in the capture subdirectory. But it knows not to watch those again, otherwise it would go into a recursive watching scheme that would just explode, because files would get created and then more triggers would get kicked off. But it knows to ignore the stuff that's being put in the capture directory. So now that the zignore file is created, if we just go back to this diagram over here, the zignore file is created, and we start capturing metadata, expecting that mtables are going to be added in the subdirectory also. So I'm going to copy some of this data that Robert has created with these timestamps. So okay, we're copying the IT data, mtable data, in this window. And copying the FDNS mtable data from this other window here. This is going to take some time. And meanwhile, I'm going to have to leave this and come back to it a little bit later when it's done. Okay, so while that's going on, looks like we've got a lot of gigs left to go. So let's just go back and talk about a few more things here. So let's just review what's going on over here. That we initiated 3 different table copies, okay, and in turn, each of those trigger an event. One of those events, its logs was captured in this window right here, as you can see. This was the beginning of the capture session. When these two, when the mtable files finish copying, I will conclude the session by removing the zignore file. The zignore file removal triggers a build, and what we do in that build is essentially we have a couple of input variables. One of them is this mtable update S3 directory, which tells us the subdirectory that we were capturing data from. In this case, it's data to FDNS mtable. Another one of the inputs into this job is the snapshot ID of the existing data. This is currently a value that's hard-coded in one of the templates of this automation layer. With those 2 input parameters, then the script winds up, a script called copymtables.pl winds up capturing the data from that subdirectory and overlaying it onto the snapshot. And in the process, it also winds up removing other files that were of the same pattern. For example, an older timestamp of the same FDNS mtable file will get removed. Same with other files that were added in this capture session that match the same pattern, where the file pattern is the same. Then tests are run, and we wind up with sort of this decision to what to do when we have success versus failure. So currently, if tests pass and we succeed, everything is fine and dandy, and we wind up with an AMI image. You could take that AMI image and deploy an instance from it, and it would have the latest data, and we'd be able to then use that if we update the CloudFormation load balancer config to deploy it out to the farm, and then the new AMI would be deployed out there. Now, if things don't go right and the tests fail, we do not generate a new AMI image, so it doesn't really break anything, but it does currently wind up not so clean in that the data that we copied into the S3 bucket is kind of still there, and supposedly it failed, and it should be removed. So this part hasn't been implemented yet, but what I plan to do is we plan to fail any captured data into a subdirectory that just moves it aside and keeps the S3 bucket clean portion separated from the failure data and metadata. And then we want to generate an email about the failure, and this process winds up, even in the case where the tests don't pass, generating an intermediate AMI image that actually has the overlay data in it, and you can SSH into it and run tests and see what failed. Okay, so we're back, and looks like the mtable copies have completed. There is one of them and the other. And so let's do a quick listing here of files. Yep, it looks like we get the two new mtable files. We've got the zignore file that we dropped in there. This is on the S3 bucket side I'm looking at. And we've got 3 capture events. Each one of them is associated with in the S3 events, the file creations, zignore, and the 2 mtable files. So now I'm going to issue the last command to trigger the completion of this capture by removing the zignore file. File is deleted, and let's see here. Okay, and looks like the end capture event was triggered by the zignore file deletion. And now if we jump over to okay, let's go see, let's look at code build jobs. And you see that the job's been kicked off. And this job, let's take a look at some of the build details. As the mtable parameters that specify the directory where the data is being captured from. And if you look at this, it's running the copy mtables script, which is walking through the captured data and copying the data over to an AMI instance that's being spun up. It's starting with the IP and then the FDNS tables next, and once that's copied in, it's going to do a little bit of data retirement of like older tables, and then it's going to run tests. So with that, I'm going to go ahead and pause the video again until this process completes. Okay, so some time has passed and the code build job we were looking at has completed. Scrolling through the logs here a little bit. Essentially, mtable files were copied in place. Appropriate ones were retired. Tests were run. There's this test suite right there, and an AMI was generated. So I'm just going back to our S3 bucket here. As you can see, the mtable files in question are copied in the proper place, and you'll notice that the captured directories are actually gone. They're copied into an archive directory at the top level of the S3 bucket. We could take a look at them. It's tucked in here somewhere. Anyways, the job has succeeded, and at this point we can deploy the AMI and test it out. I mean, well, it's already been tested, but we can deploy it to the load balancer, or we can deploy it to a particular instance if we just want to kind of play around with it. So I'm going to do that. Okay. Oops. Okay, so we have these two instances. Should have an alias here for SSH and box with the proper key and everything. It's still not up. Give it a few seconds here. There it is. Okay. All right, looks like the data files are in place, and you can see the older ones were retired. So keeps the size of the disk in check. We can run the test suite here if we want, but it's already been run in the code build job. Okay. All right, so yeah, at this point, this AMI is ready to go, and we could, for example, go ahead and deploy it across the load balancer farm. And that's the end of the demo for now. So you can create the system. It works for really the positive case when nothing goes wrong. The build could fail due to whatever reasons, and right now, like, the system doesn't really recover too cleanly, but that's something that remains to be implemented. Also, once we do run a successful job and get an AMI, right now we still have to go through a couple of manual acts of updating a snapshot ID and an AMI image ID in two different files in the outside Intel repository. And those wind up being used in the next deployment using CloudFormation across the load balancer farm. These things should really be turned into parameters across another code build job that would essentially make this something anybody could click through and deploy using the AWS console code build interface, rather than having to check out code and update snapshot IDs and AMI image IDs. So that remains to be done as well. So to do tagging and parameterization, what I was just talking about, and better failure handling in cases when things go wrong and we need to copy cruft data that was invalid perhaps into a failed directory. Okay, with that, I'm going to close out the demo.